Hello. Hi, everyone. I think we're going to get started. Thank you again for coming to the Winter 2020 Midday Talks. And before we begin, I'd like to acknowledge that the land that we're meeting on is the traditional territory of many nations, including the Mississaugas of the Credit, the Anishinaabe, the Chippewa, the Haudenosaunee, and the Wendat peoples. This land is also now home to many other diverse First Nations people, and all settlers, including recent arrivals, have a responsibility to consider what it means to acknowledge the history and legacy of colonialism in this and other lands. I'm very excited to have Joseph Vidich joining us today. Joe is the co-founder of Kin and Company, which you see here, a Brooklyn-based furniture and interior design practice that specializes in metalwork and fabrication. Founded by Joseph and Kira de Paula, the studio has recently shown their premier collection at the Sight Unseen Offsite and Wanted Design. Their studio was named Sight Unseen's 2017 American Design Hot List and was recently awarded Maison and Objets Rising Talent Award for Furniture Design. Kin and Company continually pursues innovative material experimentation. Today, you will see some recent research on metal folding, patinas, and heat tempering. Joseph's background is in architecture, having received his Master's of Architecture from Columbia GSAPP, and currently teaches studios and courses that specialize in architectural detailing and digital fabrication at Pratt and City University of New York. I've known Joe for quite a while. We went to undergrad together, actually, and I'm very excited to learn more about their work and experiments on steel. So let's please welcome Joseph Vidich.
Thank you so much, Vivian. This is my first time in Toronto, and it's an honor to be here. I'm really excited to present this work. It's given me an opportunity to really focus, or let's say refocus some of the projects that we've been doing and think about them in a different lens, in a different context. So I'm really excited to actually have the opportunity to put this together, and I hope you enjoy it. So, Kin and Company, as the name might give away, is a collaboration between myself and my cousin, Kira de Paula. So we did not grow up together. We grew up on separate coasts, but we've known each other our whole lives. And my background, as Vivian said, is in architecture. I went to a graduate school for architecture at Columbia University, and I've been teaching ever since. And I have a background in metal fabrication, basically. And her background's in interior design and in high-end furniture. So we started our company about 8 years ago with the idea to really reinvent the way that metal is seen, both architecturally, but also most importantly through furniture, through the object, through our experience as objects in our spaces. So we're Brooklyn-based, New York City, Brooklyn design build studio, and we really use metal as our primary material. We really focus on precision in detailing, material experimentation, material exploration, and really thinking about surface itself as a means through which we can apply some of our research and transform some of the what is otherwise a very kind of banal, simple material, a sheet of steel. So here you'll see, this is a collection of not all of our work, but kind of a good example of the variety of the different work that we do. And the Kin and Company is really sort of threefold. There's the furniture, which is essentially the brand. When you go to our website, when you look up, when you look us up online, you're going to primarily find our furniture fabrication and our furniture design work. This is essentially how we're branding ourselves, is how we're putting ourselves out there into the marketplace. The fabrication work that we do, which is high-end architectural metal fabrication, and I'll show a few examples of that as well. That is all kind of client-based, word-of-mouth, things that we don't necessarily market in the same way. From a business perspective, they are equal. They both help to run our business, but in terms of the way we want to kind of codify the brand, we really focus on this. And this is what has gained us a lot of momentum, both through press and through awards and so forth. And then the last part is research, which ideally we try and bring, and I'll give an example of one of our research projects, but we try and bring that into all of our work, but it's kind of more easily brought into the work that we have the most control over. The architectural fabrication work is more client-based and client-driven. The wave table. So this is the wave table. The wave table, I think, is a good example. If I was to pick one piece that kind of codified our ethos and our aesthetic, it would be this table. It is very, very simple, sort of deceptively simple. It's a single sheet of 3/16 or about 3-4 millimeter thick mild steel sheet that gets curved and rolled and then heat treated. So very simple, almost no detailing. So when I say we pride ourselves on precision of detailing, this is a piece that basically subtracts all the detailing and tries to create something that is minimal, sculptural, but at the same time kinetic, same time has a feeling of movement in it. The process through which we make this piece, and we do a lot of our own fabrication. So we have a facility in Williamsburg, Brooklyn, where we do a lot of our own fabrication in terms of welding, cutting, assembly, patinas, final finishing, and so forth. This is not our facility. A lot of the stuff that requires much more complex machinery, we sub out. So laser cutting, rolling, press brake work. The reason we do that is because those machines are very, very expensive and they take up a lot of space. And we try and stay sort of lean. So we can still control a large part of the process, and we do use fabrication as a means to experiment. But we work very closely with a lot of other subcontractors. So this is Staloff Brothers. They roll all the parts for us. So we will go out and visit them. And this is basically him rolling a sheet of metal to get that curvature that we need for part of the wave table. I think what makes this particular piece so special is the surface treatment. And this is not necessarily a new surface treatment, but it's something that I think that we're kind of doing in a very different way. So tempering metal is done all the time to strengthen it, and it naturally starts to change color during the tempering process. And you can see here an example of the different temperatures and the corresponding color variation at each temperature. So this is done for knives, this is done for a lot of like hardware, bolts, and so forth to strengthen them. Basically, it makes the molecules much denser in the material and therefore creates a stronger overall object. So we had sort of happened upon this just through our welding. So as we're welding, the material heats up, it starts to change color. And when we saw this, we were like, well, can we just start controlling this process somehow? Can we actually use this byproduct of our fabrication as a finish in and of itself? And through a bunch of experimentation, we were able to start to control it. Now, it's not easily controlled. It sort of does what it wants to do. You have some ability to go lighter or darker, and this is a series of stills from a video we shot when we were finishing some of the pieces. The material will continue to change color even after you're putting heat on it as it reaches sort of a peak temperature, right? So it might end up in the sort of 500 degree Fahrenheit range, but then if it's still getting some kind of heat from an area close to it that you're putting the flame onto, it might go up to 540 or 590 and start to change color. So there's sort of like this anticipation of transformation, which is something that I'll come back to a lot in some of the other finishes that we do. Same thing with patinas and so forth, sort of anticipating how this will start to change over time, and sometimes that time is very, very short. So in this instance, the change happens very quickly. With some of the patina work, the change happens over days or weeks. But again, the process is, in terms of the fabrication for this table, is something very simple, very, very minimal, but a lot of the effort in terms of developing the design goes into the treatment of the finish and the surface. So the reason we're calling it the wave table is that it embodies this kind of cresting wave. And we've done these with 2 or 3 or even 5 or 6 leaves that curl out and fold. So the idea was to create a table that had a very fluid, a fluid sense of movement, a sense of dynamism as you move around it. You know, it'll open here as you're standing in front. Oops. There we go. Right. So as you're on one side of it, it opens up, and then as you walk around the piece, it starts to close and become more solid. So, like some of our other work, this piece also encourages the user or the viewer to constantly move around it. And when you're moving around it, and depending on the day and depending on the light at that time of day, if it's cloudy or if it's direct sunlight, the surface changes. So, you know, we're sort of capturing it in these photos in one particular instance, but it really requires someone to move around it constantly. The step chair and step stair are more, I would say, kind of conceptual pieces. This was a collaboration we did with Henrik Oldegard, a Norwegian designer, and this was through Sight Unseen. So Sight Unseen, I don't know if everyone's familiar with Sight Unseen, but they are kind of there's 2 women who started a collective to feature avant-garde, up-and-coming designers in lighting, furniture, objects, etc. And they've kind of grown a pretty robust following in New York and then outside of New York as well. So they do this thing, Norway by New York, Norway x New York, for the last few years, where their Norwegian consulate takes 7 or 8 Norwegian designers and pairs them with 7 or 8 New York designers, or American designers, not always New York. And so this collaboration happened, you know, digitally for the most part, because we were in different countries. But our idea was to really look critically at you know, what is a chair and what is a stair. Sometimes a stair actually is a chair, and sometimes a chair is a stair. So, you know, we were kind of playfully thinking about this ambiguous understanding of how a piece of furniture, the utility of a piece of furniture, essentially, and thinking about what does it mean in terms of the height of the tread, or the height of the rise of the step, or the length of the tread. You know, how do those start to intuitively make you think chair versus stair? So a lot of the ideas that we wanted to come back to were these ideas of ambiguity through the utility of the object. This idea of the sort of, you've probably seen something like this kind of folding chair ladder. And then this idea of floating. And coming back to metal, we were the ones who were going to manufacture the piece, coming back to metal and thinking about what we can do with metal. It can bend, it can also float in terms of thin plates. You can perforate it. So this was our sort of our mood board, our concept board to get started. And then we really just worked through hand sketches. This was a process that we both us and Henrik, very quickly, actually, it was almost funny. It was like our first Skype meeting, and I had sketched, like he had sketched one of these sketches up here, and I had sketched something. It wasn't these exact ones, but it was like very, very similar. And we were like, you know, opening our email simultaneously, and we're like, oh yeah, so a stair? That's kind of like a chair? We're like, yeah, it's a chair stair. And it was like almost the collaboration, or the concept was so seamless. We were like, is this really the project? Like, that's it? We figured it out? And then obviously it went through a ton of iterations, because it would prove to be harder to make a stair, chair, chair, stair than we figured. But it was really nice to kind of have this moment of where potential collaboration, which can be difficult sometimes, collaborating with someone you've never worked with before, actually started so seamlessly and effortlessly. So quickly, we started developing a very, very simple digital models. Again, just looking at like the basic parameters of height, width, depth, and then starting to add more nuance into those, right? The sort of squiggly lines, the cuts, how do you start to kind of penetrate or open or in some way kind of dissect these pieces to make them more playful. And I think that's one thing our furniture, not always, sometimes it's more serious, but I think in general we try to, part of our aesthetic is trying to develop pieces that are playful in the way that you might interact with them. So we use Rhino exclusively. We do all our drawings in Rhino. We output all our fabrication files through Rhino, so we'll make CAD drawings through Rhino, send those out for fabrication. We do all our design work in Rhino, once it gets to the point of, after we're sketching. And we pretty much 3D model everything. And that's true both for the furniture side of the work, but also for the fabrication side of the work, because inevitably, I don't know, I think it's maybe partly just my background and just the last 10 years of digital modeling. When I was in grad school, Rhino just started becoming a more ubiquitous product within architecture, and so it was just something I started with. But I do find that digitally modeling has a unique ability to give you a different sense of, sort of moving around the piece. I would love if we could just also have the time and money to 3D print little mini versions of everything. Maybe later. But for now, this works really well. Rendered them out. So in terms of finishing, starting to think. So I guess I kind of jumped a little bit. Hang on one second. So the next steps there was a bunch of steps between this and the next image, but basically we went through this iterative design process where we ended up with kind of a low step, let's call it. This was the step chair. So this low step that has the ability to be a step stool, maybe, but also you might sit on the back of it, you might put plants on it, and then we integrated these very thin, so like 3/4 inch diameter, like 20 millimeter, very thin tubes that added some stability. There's a little bit of a leg coming down in certain places that added stability, but then also added another place to introduce a new program. So maybe you would hang your scarf there. Maybe you'd hang a blanket there if it was next to the couch. And this would be the chair stair, so something that you would sit on more at chair height, but again, you could also walk up this if you had to reach something high, and you could also use this to stack something, right? Maybe you put a plant there, maybe you put magazines. So we were thinking of these really as domestic objects, but these ambiguous domestic objects that the end user, whoever was to buy these and bring them into their home, the end user would really define the final function. So one person might use the stair chair as a coffee table, and someone else might put it in their kitchen, and use it as a stepping stool and something that they, stored pots on, So it really became an object that had a sort of wide potential for different utility. So these were earlier versions, and this is renderings of what we ended up with. So the stepping stair chair, and then the more, I guess, still stepping chair stair, but thinking about carving the surface away. So this was, as we were developing those earlier pieces, it felt too solid, right? So we really wanted to think about the surface, not just undulating and folding in one dimension to give it the necessary kind of rise and run, but also in plan, starting to cut away to pull out as much material as possible. So by doing that, by pulling all this material out, then we had a very kind of critical engineering problem, which was that they were not stable at all. So there was a lot of, we knew that we would have to have these tubes early on as a way of structuring this and giving it stability, but we didn't really know where we were going to put them. So there was a series of kind of mock-ups and some prototypes made to study that, and then we decided to cut those tubes into the surface themselves to then add even more sort of ambiguity to programming. So maybe you would end up with this could become a vase, right? You could put a plant in there, you could put an umbrella in here. We had one client who is thinking about putting these by their pool, right? So just like adorning the side of the pool for towels, and like you can chill some champagne in there. So again, it was really interesting to, as we introduced this to the wider world, to sort of see how people interpreted the use. So these don't just kind of make themselves. There is besides 3D modeling, there becomes a very in-depth process of shop drawings. So this is some of the CAD drawings that I was mentioning earlier that we would then send out to our fabricators. And usually what we'll do for more complex pieces like this is that we'll send them, sometimes we'll send them the actual 3D file if they have, not all of them can interpret or open those files, but if they can't, we're always sending a 3D axon and then very detailed drawings of how they need to fold and bend this. We actually ended up getting a specific tool made, which I had a photo. Now I'm realizing I should have brought that photo too. Forgot about the tool that we had them make. So this is this type of bend here is actually like a kind of complex bend to make. You can't just sort of put it into a machine that does like very clean. Bending folding a piece of metal is pretty straightforward. You can put it into a machine that will bend it as a tool goes into a die and fold it to whatever degree you need. But to get this, but those are very sharp angles. To get these very subtle curves here, where we're talking about a 2-inch radius, they have to do lots and lots of little tiny bends, which we didn't want them to do because it was going to become very expensive and also take a very long time. So what we developed with them was a tool that was a 4-inch diameter or 2-inch radius solid steel bar that then they welded and put into their machine, so they can just in one stroke, let's say, be able to push down on the metal and take a flat sheet and start to bend it and get that radius. So that was an advantage that we have as designers who also are builders, right? We could problem solve engineering issues or fabrication issues with our subcontractors or our fabricators because we have a very sort of in-depth knowledge of how those parts are being made. If we were just designing, then and this is more the typical route, if we were just designing and didn't have the experience as makers, the communication between us and the fabricator would be to get to that point would be a lot more complicated. We'd really be relying on their expertise, and they would have to kind of think ahead to say, oh, well, actually, it would be easier if we made this tool, et cetera, et cetera. We had then, we were in the position where we could propose a tool to them, and they said, oh, yeah, that's actually, well, it will cost you like $300 to make it, but it'll save you hundreds and hundreds of dollars of machine time later. This is some process photos of the bronze bars. So welding the bars together, applying the patina. So all our patinas are applied wet, and then some of them are with heat and some are without heat. I'll talk about that a little bit later. And then this is an example of the detail of the final bronze bar installed in one of the pieces. So this is a process we end up having a lot of control over, and I'll get into this a little bit later on another project. So here's the final piece, the chair stair. This is with a kind of, it's a little hard to see, but there's actually like a rose gradient. So it's just regular bronze, a kind of bright yellow at the top, and it's pink at the bottom. And then blackened steel, so that's a patina. It is a black. It actually does oxidize or rust the material, but it turns it black, and then you stop that, kind of like how you'd put like a photograph back in the day. Maybe you don't know about stop baths for photos, but as you're developing a photo, you have to stop it from kind of continuing to develop. So you sort of stop that from continuing to oxidize and rust, and then you apply a lacquer, and then this leg is powder coated. So the color, and then inverse here. the leg is blackened, and this has this sort of, you can't see from here, but it's a very sparkly, super glitter. 2018 was all about glitter. Powder coat. So for us, the thinking or the concept behind the colors here was sort of like the night sky, you know, making pieces. This particular palette was like this idea of like the night sky, the blackness of night, the glittering of the stars, the two pieces together. And then I like this photo because it's kind of what, to me, like, do you remember from one of the first slides I was showing, the magic carpet floating, right? Like this, I like this slide because it was like, oh, this image, right? Like this nail, like this is what we were really going for, right? This is the magic carpet. This is the idea of taking a sheet of metal, which is heavy and banal, and turning it into this like very light, almost this effortless floating magic carpet. So, you know, I'd love if they could all just float with no structure whatsoever. The Cascade Mobile. So we've done several of these, and these, this project started, I'll show you kind of there's several different versions in here, but they're all kind of mixed in together. It's all sort of the same family, but just different iterations of it. This project actually was for a client in Montreal. This is the home, this is their house, and it was going in, it's kind of like a very difficult space to shoot because like the ceilings here were pretty low, and then it opens into this double height space with this curving stair, and the architect was a disciple of Frank Lloyd Wright, whose name I can't remember right now, but so a lot of heavy wood, rich kind of material palette, a lot of, you know, all these are sort of bronze little kind of connection pieces. So yeah, this was a project going into Montreal, so that was very exciting for us, and going into a pretty interesting space. And the client was very excited about. They gave us a lot of latitude with the project. They wanted something that was very sculptural and playful, and but that was kind of it. You know, they had said mobile, and that was like the whole brief right there. So that was great. For us, we hadn't ever done a purely sculptural piece. Everything had some function. So that was exciting to do something that was purely sculptural. And also something that we can really start to play with all our patina work. So at that point, we've been developing a lot of different patinas, and we thought this would be a really good opportunity to start to play with patina and play with finish in general, the heat treat, mirror polished metals, and so forth. So conceptually, this was the board that we sent them. This was our mood board. And what we wanted to do was something that that kind of evoked this sense of lightness, a sense of flying, flocking, and had almost like an orbiting quality to them, like planets in motion or stars in motion or comets with glittering tails on them. And very geometric, you know, and I think you'll see all of our work in general is very geometric. You know, we really do come back to pretty fundamental shapes, triangles, circles, half circles, squares, things like that, and arcs, a lot of arcs for now. This was our first prototype, so like it kind of looks like a mess to me, to be honest, and we like showed this to the client, and I think they were kind of okay with it, but they were like, okay, what's next? But actually what we really liked about this, like the design, two things, this was another advantage of being able to both design and then make, right? So we knew that we knew that mobiles were not easy to do, but they were really, really, really hard, like way more difficult and involving much more math than we had anticipated. We were like, we'll just get these shapes and then figure out like what's the balance point and then put them all together and it'll be fine. But like we're basically calculating the weight of everything to the gram and doing like some pretty reasonably complex math. But this was our first test where we were like, well, let's just see if we put things together, how does it work? Like, can we make this work? And we realized that our initial designs, which had pieces like this connecting in the middle with other pieces hanging off the ends, and then all of these sort of cantilevered parts created so many variables in the way that the objects were going to distribute their weight, that we realized, like, there's a reason why there's like one string, and then off that one there's another one, like all kind of in a line, because you can really counterweight like a big heavy object on one side and then all these small little objects on the other, right? So like, this makes a lot of sense. What we were doing was kind of multiple arms hanging down off of one another with no clear sort of center of gravity. There was like multiple centers of gravity. But this looks pretty simple, right? You're like, yeah, that should be totally straightforward to make. So this taught us that like we actually needed a lot more refinement to the design. But it also showed us that the shadows were super cool, which was another thing we hadn't really thought about, which was great, because then that led us to a conversation with the architect for that house to say, or let's say the architect who was renovating the house, to really think about placement of the lights, which we hadn't thought about we thought about it, but we hadn't really realized how provocative some of the shadows could be in what was a relatively tight space. So initial studies, that then led us into starting to, I'm jumping ahead a little bit, but that then led us to a whole series of design studies where we were looking at shapes, looking at patinas on shapes, and then also starting to refine this. And this is where the sort of cascade comes from, where it is now sort of center. There's a sort of center point of support, and then there's two arms, and then off those arms, everything kind of drops evenly. So this whole arc is supported by, counterbalanced by that, and this whole assembly is counterbalanced by this whole assembly, and then that's balanced in the center. So that simplification made a huge difference. And then also looking at custom hardware. So we knew that we were going to really have to, for the first iteration, we just bought stuff off the shelf, and you can see some of that down here, or maybe back here. These are some of our calculations as we were making the pieces. So this was the very first one we made. There was a lot of like learning as we were going. We would make it, and then we realized that we needed, like, in these were laminated sheets. So there was like a bronze piece with a piece of steel in between, and then another bronze piece on the other side, and we would start to add or subtract as we had to balance this out, realizing where we needed more weight or less weight. This was before we realized how much actual math we had to do, and we were just doing it by kind of visual calculus. Then we created more robust spreadsheets. But all of this is to say that as we developed this project and this product further, we started to refine the entire process. So really being able to calculate the shapes needed, how the arms would have to be positioned in order to balance each other, going from store-bought hardware to custom hardware. And that's actually something we're still refining for this piece, because everything is, again, so minimal. You've just got these arcs and these shapes, so the hardware really stands out. This particular piece that we put into the client's house is pretty tall. It's like 10 feet tall. And then, again, studies to the patina. So I'll kind of back up and talk patina a little bit. So we had thought about this piece as an opportunity to really explore finish. So we hadn't really explored that many finishes besides some of the powder coating, the black oxide patinas, and some very simple like verdigris patinas for like these ones here that you see, sort of the typical stuff you'd see on bronze. So we really wanted to use this mobile, since it was purely sculptural, as an opportunity to explore patina. And for those of you who don't know, are like, what is patina? So any metal is going to oxidize because of oxygen in our environment. And the oxidation process that's where you see rust. Or you see metals starting to turn, like aluminum will start to turn gray, steel will rust, bronze and copper will start to turn pink and green and so forth. So it's just kind of an oxidation of the surface molecules. So what we wanted to do was use the different chemicals, and there's a huge different array of chemicals and different dyes that you can use to accelerate that process. So basically the chemicals for us act as a catalyst, and then the metal is a canvas that we can start to develop all these different patinas on. And that's something, just like the heat treat it's out there. People have been doing patinas for centuries, thousands of years. But that was a technique that we saw lacking, especially in this high-end furniture market and in sort of the high-end architectural design, interior design world. So we knew that we could, and we knew that this was something that we could really learn a lot about and kind of own as part of our brand, essentially. So this was speculative studies of what patinas could be, and then the patina process itself. So again, going through lots of testing, developing an array of different types of patina. So some of these use dye. So some of these are sort of like slightly faked. It's like partly oxidized, but also partly a dye. Some of these are just stopped at different stages in their process. So this one, this one was basically the same chemical that we use to turn it black. If you were to leave it for longer, it starts to turn these colors, and then if you leave it for a really long time, it will just start to turn, orange and red. These are different bronze patinas. So we did a whole study and then dialed it back to ones that were replicable, right? So we could make like these really crazy versions, but if there wasn't something that we could repeat later, then it's hard to make a saleable object, right? So if it's like, oh, sorry, we made this one cool color, but we can never do it again, and you can't buy that. That works if it's a one-off, but if we want to stay in business and we want to sell our furniture, that then forced us to really think about, all right, how can we get some consistency? The patinas are always going to be different, and the heat treat will always be different, and that's just part of the education that we have to give our clients. But there has to be some consistency, right? It can't be green on one piece and blue on another. And here is the two different versions, actually, of final pieces. So two different mobiles. This was one that we brought to Paris with us in September for the Maison et Objet show. And then this was one of the ones that went into the home in Montreal. Similar scale, though. I mean, this is about 9 feet or a little under 3 meters. We're actually doing one of these that's like this tall right now for a client because they saw this online on our website and they were like, great, we love it. So it's going on a bookshelf, and we were like, no, that's not going to work. Like, how big is your house? And they're like, well, how big is this? Because there's no people for scale. We were like, oh yeah, we need to get some like photos of it with like a person or in a room because it's huge. And they were like, oh my God, this is like 9 feet tall. So they asked if we could scale it down, which was great. We just finished this one. We're in the process of finishing the patinas right now. But that was a really interesting kind of challenge to us. It was like, at first we were like, I don't actually know if we can scale it down. In theory, we could, but it was a totally different design at that point. I mean, the design stayed the same, but it was a totally different fabrication technique. So we're using, really thin, 1/8 inch, 3 or so millimeter thick bar instead of what these are, which was like 3/4 of an inch or 1/2 an inch. So it's like we had to really change the way we were thinking about it. But now it's maybe that's a different type of product. So just a sort of interesting aside. When you don't have scale, when people don't know what the scale is, there is always going to be an issue. So in your sections, make sure you put a couple scale people. And here it is installed in Montreal. So this photo I really like because you get a sense of sort of the galactic quality that we were trying to get, this idea of that there was these star-like or planet-like objects moving in space above you. And these do move. They don't completely rotate 360, but they have maybe about 60 degrees of rotation on either side. So if you had like the door open or the windows open in summer, and you had a breeze coming through the house, these things would all kind of like shimmer and move a little bit. Little behind-the-scenes photo of us taking photos. Documenting the work is very important and like very time-consuming and like the last thing you think about when you've just been like rushing to finish all this stuff. something maybe we can talk about in the Q&A is sort of a lot of the way that we developed these work. The original designs for these projects, like the wavetable, wasn't for a client, it was for a design show. So these are design shows that we do every year where we develop new collections, essentially. So then we have to really make sure that we develop them early enough that we can photograph them, document them, get it out to the press, because the worst, which we learned when our very first design show, is we had all this great stuff, and then press would come up and be like, great, send me the press kit. Like, where can I see this? And we're like, literally nowhere. We have no photos. So yeah, you sort of have to like really finish everything. It's like as if you had like your final project done a month before your final reviews, because then you needed that time to document it and get it out there. So documentation was very important. And this is our booth at the Maison Objet in Paris this last September. So that was a really great opportunity for us. We were one of 6 American designers nominated and then received a Rising Talent Award within furniture and lighting design. So they flew us out to Paris, gave us all booths in what is, I think, Europe's largest trade show, or second largest. Maybe Milan is bigger, but it's everything you can imagine. Furniture, interior, cars, gift objects. So yeah, we were one of 6, and it was a great experience, to actually start to move into a more international market and get a lot of feedback from potential clients who are from a very different market than what we are in New York. So the Patina performance, did you go to this, Vivian, at Storefront? Because team did something too. Okay, yeah, it was fun. So the Patina performance, this is a this was part of Storefront for Art and Architecture, which I don't know if you're familiar with. It's a gallery, a very well-known gallery for experimental and speculative work within architecture in kind of in the Soho area of Manhattan. And this was put together by a team of 4 or 5 architects last summer, no, 2 summers ago. Basically, 24 architects were creating 24 stools and 24 performances, essentially, for 24 hours of the day. So it started at, I think, 6 or 7 p.m. and then went all night. It was like this block party. We didn't stay all night, but it was pretty cool. So 24 stools. The prompt was pretty open-ended. You could make whatever you wanted. So we, of course, wanted to do something with metal and with patina. And then you had an hour, essentially, to do whatever you wanted. You could do, some people just had a dance party for an hour. Some people in the morning, the next day, did, a yoga session. Some people did, a donut making class. It was, totally random. Some people gave, a lecture for an hour, which at, 2 in the morning was interesting. So we want to do a performance of patina, actually just bringing patina to the people. So the inspiration for our piece was just the ubiquitous subway grate. So really thinking about kind of brutal but ubiquitous metal that's in your periphery every day of the week. And that translated to us to these, and we actually happened to have these bronze bars left over from a different project because there was also no budget, so we weren't going to spend hundreds and hundreds of dollars on bronze, but this was left over. So we were like, let's make a project that's just using bronze as a elevated sense of the subway grate attached to aluminum. And we did a double-sided patina. So we patinaed the bronze, the verdigris, or the blue-green on one side, and then the pink on the other, and then ran some aluminum bars through it, and just created this subway grate stool that was just very basic in its components, but again had this sense of surprise as you move from one side to the other. And we didn't seal any of this, so this stool is continuing to change, and then the aluminum and bronze, just not to go too far into chemistry, but there's a galvanic reaction between dissimilar metals. So There's a chart that you can look up. And some metals are very reactive to one another, where they will and that's actually kind of how batteries work. There's two different metals inside, and they react, and they create an electrical charge, and that charge powers your batteries. So the closer two metals are on the chart to each other, the better. But the further away they are, then you get these two, anode, cathode, I guess, and they start to react with one another. So, aluminum and bronze are not super far, but far enough to create a reaction, which we knew was going to happen. So it's been interesting kind of just watching this thing in the studio just kind of get really weird around all those raw connections, which is totally in line with what we were trying to do for this whole project, which was take, again, 24 bars. I was like, how many bars did we use? 24, obviously. 24 bars of bronze, and bring them out into the street of New York City, outside of Storefront for Art and Architecture, and give a patina demo, which people were surprisingly into, and then invite everyone to come patina, which they were way, way too into. There was chemicals spraying, and we're like, okay, slow down, this chemical, not in someone's face. But it was great. It was super exciting because people were really interested in the process, and it was fun, and we got to talk a little bit about it. And then more interesting for us was we created this, once the bars all got their patina on them, we masked out some area just to leave it raw so we could play again, like we did with the stool, this contrast between the raw bronze and the patinaed bronze, and then we sealed some of them. So the pink ones, we added a lacquer over it so they wouldn't oxidize, and then these ones we just left to oxidize, and we left it there for the whole duration of the show. So over the 24 hours, we were one of the early ones, hour 3, I think. So by the next day, it had changed already, and then it was also there for, I think the show was up for a month or something. So by the end of the show, it had continued to change, right? So and it continues to change to this day. So there was, for us, we would never be able to do this with a client, to be like, here, this piece is going to look totally different in a year and shed patina dust on your carpet. So for us, this was a really fun opportunity to just watch something decay, essentially. That's a good segue to my urn project. So how am I doing on time?
Maybe 5 minutes.
Oh, no, really? Whoops. Okay. I want to talk about, I can skip over some stuff. I want to talk about the urn briefly. So this was a project for a gallery show in New York City, and we used the inspiration of these polished Egyptian mirrors. So again, bronze, polished to reflect, which then eventually decayed and started to rust. And we had a lot of leftover material in our shop, stone and bronze. So what we wanted to do was, still using very geometric form, very simple, a triangle, a line, and a half circle, develop a project that was an urn, and we were calling it, this kind of play on words, the remains urn. So it was made from remains of past projects. So all of this was leftover stuff that we had just from other projects or things we found just on the street in a stone yard, brought it all together to create this urn for someone's remains. And then for the show in Paris, we worked with a glass artist in Los Angeles and tried to refine this a little bit to make it a product and turn it into a lamp. So this was a piece of glass that changes colors with a specific spectrum of LED light. And then just super quickly, I'll go through these stairs, which we can come back to. So we as I mentioned earlier, we do fabrication. So a lot of it is, it's all interesting, very high-end kitchen doors, interior partition walls, but they're relatively boring, not the most interesting thing to look at in this context. But stairs, I think, are a place where we can be much more inventive. These two stair projects are both cantilevered stairs. So this was, we were working directly with an architect who was a friend of mine and with the client to develop a floating stair where really the treads are coming out of the wall. And in order to do that, we had to take what is a very, very robust stringer, embed that in the wall, and then all of these supports are hidden inside the wood box, essentially. And then these holes are for these post-tensioned rods in order to support the ends of the treads, right? So we basically had to like make the treads, instead of leaving them flat, we had to actually bring them up, 15, 20 degrees based on an engineer, on what the engineer told us, in order to then, when they were weighted, they would end up going back flat. So, a pretty complex, pretty basic components, but a pretty complex set of installation and integration into the treads themselves. And this is the assembly in the wall, fully post-tensioned. This one, basically needed no post-tensioning, but by the time you got down here, there was going to be like almost an inch of deflection. Like if it didn't have those rods, someone stood on it, it would start to sag an inch at the end. So we had to pull it back up around 3/4 of an inch. Fully detailed shop drawings, both for us in terms of assembly, but also in order to figure out all the detailing and for sending out for getting components made by other subcontractors. And then a detailed view. So everything hidden, right? You don't see any of the connections. And then this stair, even simpler in many ways, the client wanted to create a sort of waterfall effect using the thinnest wood possible with the least amount of structure possible. So what ended up happening was all the structure was a stringer on the back wall, and then these flush, these angles that are embedded in the back of the treads and flush. So in order to do this, we needed to actually build like a pretty big, like it was like a 1/4 of the stair prototype, because there was a lot of movement. So the engineer that we work with said, the stair is going to be fine. Like the stair is not going to fall, but it's going to have a fair amount of movement. So if you walk up this stair, you actually feel the stair kind of undulate a little bit, which the client was so adamant about having the thinnest possible stair. They were like, that's fine. We don't mind this movement at all. So it's all, structurally sound, but it's like this serviceability issue, which happens a lot of times in architecture, where things are overbuilt, not because they need more structure, but because they actually need to feel okay when you're using them. But one issue, so this is a stringer, so very, very basic, right? Laser cut parts that we subcontracted out. These angles are welded in to capture the back of each tread. Set of shop drawings, and then the stair itself. Now, one issue we did come up with was that we worked with a woodworker who doweled in all the joints. So one issue was that metal and steel have different coefficients of expansion, so naturally they're going to want to separate and breathe a little differently. That was easy to account for, but because there was so much movement, the harder thing to account for was some of the separation on some of the treads. To be honest, it was way less than we thought. Like the woodworker and I were like, we're going to be back here in like 6 months, patching all these cracks. But actually there wasn't. There was very few, and it was partly due to the way we separated on the inside angle here, the way we separated some of the wood, so that there were moments when it might, if it was very, very dry in the house for periods of days and they were using it a lot, it might separate a little bit, but then it would go back. So the stair itself kind of breathed, which was interesting. Should I click through this quickly? This is basically student work from a course I taught for 8 years at Columbia, focusing on speculative rain screens. Speculative rain screens, and we went through, we had engineers we would bring in, fabricators that we would bring in, rain screen fabricators, engineers that did facades, and the students developed a full semester course. The students developed very detailed drawings, starting from concept through mock-ups out of chipboard, and then full-scale drawings, full-scale mock-ups for the midterm, looking at lighting, integrating other programs into the facade itself, and then shop drawings, visits to the fabricator who then cut all their pieces for them. We were just working with sheet metal. That was part of the constraint of the course. And then the final full-scale components. So these were very speculative, very conceptual, but pretty fun in the way that what can you do with sheet metal at the scale of a facade when you didn't have to think about weather protection, right? It's just a simple rain screen. And then part of the end of the year show at Columbia. And then I can leave it here, sort of studio photo.
I think we have time for 1 or 2 questions from the public, if there are any questions. I mean, I see a hand. I just want to jump off. I don't have a question, but I want to say that I really appreciated, knowing that a lot of our students use Rhino, that you're showing projects where we see the simplicity of a design without gravity, as a surface and a software program, and then seeing you tackle that and maintain the minimalism, but realizing all of the calculations and the thought processes, whether it's jigs or tools or, to kind of maintain the minimalism, but make it in gravity and a reality.
That is like one of the harder parts.
Right.
Yeah.
Hi, thank you for your lecture today. It's really interesting to talk about the metal panels in your work. And my question is, for the metal that symbolize zero gravity, what kind of software do you use to actually do the parametric part? Do you use Grasshopper to modeling?
Yeah, we don't. So we're not often doing that much parametric modeling in terms of like when we develop the form, a lot of it is just sort of analog modeling. We don't use Grasshopper like the rise over run would work. Or if we were testing, maybe different radii for those folds and bends. But we're not using Grasshopper too much for the pieces that we're fabricating. We will use SolidWorks. I don't know if you're familiar with SolidWorks, but SolidWorks is it's a sort of fully parametric software that handles sheet metal very, very well. So it will, one issue that we have with Rhino is that when we make something in Rhino, and then like if you were to like fold up a box, and then when you unfold it, it unfolds it like the exact dimensions of that box. But maybe it is not super intuitive, but it's flexible. Metal is actually not that rigid. It can really bend, which is part of the reason why it works so well with concrete, because it helps, it sort of, the elasticity of it helps concrete not crack as it starts to deflect. But so when it bends, when it's being folded, Rhino can't take account for that. So we'll use software like SolidWorks, which is parametric. It's constrained and related back to itself through a whole series of parameters, but it will account for that deformation when you unfold it, so you get an unfolded sheet that's actually slightly smaller than the folded sheet because it has to account for that expansion. So no Grasshopper really, but other tools.
One more question. Okay, in back. Thanks. Are you going for me?
I don't know what the question is. Where's the question?
Thank you. Thanks very much for a great talk. I did have a question about the movement from Rhino into the final piece. And you talked a little bit about it with the mobile, but not necessarily with the stair chair stair.
Mm-hmm.
At some point, I'm assuming there's some kind of full-scale mock-up to test the potential thinness of the metal, its rigidity, if it's not rigid enough, and so on and so forth. And I'm wondering if, is that a series of cardboard mock-ups, or do you move directly into full-scale mock-ups in steel or in metal?
Yeah, that's a good question. So we will do mock-ups at full scale to kind of look at like the form, but actually doing it in cardboard or wood, the properties are so different than steel or metal in general that like you don't really get a true one-to-one for like how the material's working. So basically we've done a lot of earlier projects, which I didn't show, which were using thin sheets of metal to create these series of folded seats and folded stools. So we knew from experimenting on earlier pieces. So there's like the full-scale mock-up is actually just us making a piece of furniture and then getting that back from the person who's doing all the laser cutting and the rolling and welding it together or adding and subtracting structure. So we knew from earlier pieces of furniture that, let's see, I probably have it in that very first slide. Like these ones here at the top, sort of center, those are some of the earlier pieces we did where there was this single sheet of metal that then sits against a wall with a cleat, and we knew that the span of the depth of that seat would allow for a certain, we didn't know this ahead of time, but we knew afterwards that it allowed for a certain amount of deflection, and we could extend that span X amount of inches without it deflecting. In the center of it had 2 supports, but if it was cantilevered, it needed more support. So there was a lot of earlier experimentation and refinement of other pieces that then when we got to the sort of stair, chair, chair, stair, we knew the constraints that we were limited by. But these large shelves here, these are the sort of same family of design. These are 8 feet tall and 5 feet wide with that same, and 12 inches deep, with that same thickness of material, that same sort of 3/16. And these, at that scale, we actually hadn't worked before in terms of that specific material. And when we got those, we have some cross bracing, but we knew that we were going to have to tie these back to the wall. Like these can't really float in the middle of space, but we didn't know where or how much. So there is a lot of intuition involved just through experience, building up sort of a body of knowledge. But even with that body of knowledge, after 8 years, we're still, if we're getting a new piece that's kind of beyond the scope of that knowledge, we're getting it, and then we're spending time with it, experimenting, and that's often why the very first piece we make is technically a prototype, and then if someone wants to buy it, we have to make a new one. We can't sell that one because we have to then say, well, what we learned on this mock-up / prototype / full-scale piece of furniture, what we learned on that now needs to get translated to what would be the final piece. So
thank you.
You're welcome.
Okay, Joe, thank you so much. That was an incredible lecture. And for those of you in my class, we're going to take a 15-minute break because we will need to close the dividers for today's class, and you will need to sit in the first 2 halves or 2/3 of this room. Okay, thank you very much.
Thank you.